In this video, we will review the key concepts covered in Units 3 and 4. So we're going to start with Unit 3, which we talked mostly about inverse variation. And so when we deal with inverse variation is basically when one variable, either x or y, increases, the other variable decreases. So we have an equation we can use for inverse variation, and that equation is y equals k over x, where our x and our y are just our variables, and k is what we call our constant of proportionality, or sometimes you'll hear it called the constant of variation. All right, so if we want to be able to figure out a value that we're missing, we have to have this k, because this k is kind of what holds this whole equation together. And so if you have an x and a y but you don't have a k, you can always find the k by doing x times y. So if we look at number 1, it says if p and q vary inversely and p is 21 when q is 8, determine q when p is equal to 24. So the first thing that we have to do is it gives us our two variables, and we can change them to x and y if we want to, just to make things a little easier, because we're more used to using x's and y's than we are p's and q's. All right, so if we wanted to do that, remember you've always got to get your k first, because that's the piece that's going to hold your two numbers together, your two variables together. So we're going to start with doing our k first, and that's our x times y. So if we wanted to get k, we would say 21 times 8. And if you did 21 times 8, you get 168. So 168 is going to be our k. So now that we have our k, we're going to ignore this x and y, and we're going to use our new x and y. So it says determine y when x is equal to 24. So if we want to get what y is equal to, we're going to plug it back into this formula here, y equals k over x. Now we know that our k is 168, and we know that our x is 24. So we would say 168 divided by 24. And you would get 7. So our y is equal to 7 when our x is equal to 24. All right, so we've got on number 2, p and q vary inversely, and p is 9 when q is 6. Determine q when, that should say p is 3. All right, so we're going to use the p and the q this time, but remember that those are really just x's and y's. So the first one we've got to do is get our k. And so to get our k, we're going to use what they give us here, so 9 and negative 6. So we'd say 9 times negative 6 to get that our k is equal to negative 54. So now that we know that our k is equal to negative 54, we want to get our q when our p is equal to 3. So to be able to do that, you're going to say you're going to say q equals negative 54 over 3. And when you do that, you get negative 18. All right, number 3, when renting a limo for prom, the number of people is inversely proportional to the cost per person. So think about that in reality. The cost of renting a limo is, let's say, $200. So if the cost was $200, the more people that I have getting in that limo, the less each person is going to have to pay. So the number of people is inversely proportional to the cost, means the more people that you have, the less it's going to cost. So originally there were 10 people and the cost was $20 per person. If the cost was, or if the number of people changed to 4, what would be the new cost per person? So this is still an inverse variation. So we still have this. We still know that our k is equal to our x times our y. And in this case, our x is going to be our number of people, and our cost is going to be, or cost per person is going to be our y. So we're going to start with getting our k. So that's going to come from using our number of people and the cost that they give us. So 10 times 20. So if you do 10 times 20, you would get 200. So this is saying that the cost of the limo is $200. Now, we're going to change the number of people that we have to 4. So if we change the number of people that we have, that would be our x value. So we're going to change our x value to be 4. So now we're going to say y equals 200, because that's our k, over 4. So if we do 200 over 4, we would get $50. So if only 4 people are going, they're going to have to pay $50 each. All right, number 4 has to deal with the topics that we talked about in Unit 4, which was about radicals. So whenever you are dealing with radical equations, you're always trying to solve to get your x to be by itself. But the problem is, this time when you're doing radical equations, your x is going to be in a radical. Remember, we talked about radicals earlier in the week when we were reviewing the material from Unit 0. So the first thing you're going to try to do is get your radical to be by itself. So anything that is on the same side as the radical but not underneath the radical, so not part of the radicand, is going to have to go away. That means the first thing we're going to get rid of is this -2. So we're going to add 2 to both sides. So when you add 2 to both sides, you're going to end up with the square root of x plus 9 equals 3. And then we want to try to get this stuff to be by itself. So we've got to get rid of this square root. To get rid of that square root, we're going to square it. So squaring a square root gets rid of the square root. So when you do that, you're going to end up with x plus 9 equals 9. 3 squared gives you 9. Now we want to get x to be by itself. So we're going to subtract 9 from both sides, and when we do that, we get x equals 0. Now, whenever you solve radical equations, you always want to check for extraneous solutions. So extraneous solutions are solutions that seem to work, but when you plug them in, they actually don't. Now, if we try this, we would start with our original equation, and we're going to replace our x with 0. So we're going to have 0 plus 9 minus 2 equals 1. So underneath our radical, we would have 0 plus 9, which is 9. So square root of 9 minus 2 equals 1. Square root of 9 is 3, and 3 minus 2 does give us 1. So this is our actual answer. Our solution would be 0. Now, if we plugged in this 0 and it turned out that it did not work, that would be what we called an extraneous solution. So it appears to work when you first solve the equation, but when you go to plug it back in, it doesn't actually work. As long as it works, everything's good. Number 5. We've got the square root of 44 minus 8x equals x minus 7. So remember, your goal is to try to get your x to be outside of this radical. You want to get your x's all to be on one side. So the first thing we're going to have to do is, because we've got our radical isolated and we do see that we have an x inside our radical, we need to get rid of that radical to start. So if we're going to get rid of that radical, we've got to say what kind of radical is it. So this is a square root. To get rid of a square root, we're going to square it. So if we square one side, we also have to square the other side. So when we square the left side, remember that a square and a square root are going to cancel each other out. So we're just going to end up with 44 minus 8x on the left side. But on the right side, this x minus 7 squared means that I have x minus 7 2 times. Now, if you'll think back to the review that we've done earlier in the week, when we see two sets of parentheses side by side, not separated by anything, that means that we have to do a box to be able to multiply those two things together. Because two parentheses side by side, not separated by anything, means that they're being multiplied. And the easiest way to do that is to distribute every piece in both sets of parentheses to each other. And to just make life a little easier and see all the pieces separated out, we do that in a box. All right, so x times x gives you x squared. X times negative 7, negative 7x. Negative 7 times x is negative 7x. And negative 7 times negative 7 is positive 49. Once you get that, you're going to take everything out of the box, and you're going to combine your like terms. So when you combine your like terms, that would be your negative 7x is in the middle, and you'd end up with x squared minus 14x plus 49. So now on the left side, we have 44 minus 8x equals x squared minus 14x plus 49. So now we've got x's on both sides. We're going to go ahead and get all of our x's to one side. So I'm going to add 8x to both sides. That'll give you 44 equals x squared minus 6x plus 49. And we want to get we want to solve for x, but notice here you've got an x squared, which means that you are going to have a quadratic. So to be able to solve a quadratic, you want to get everything all to one side so that you can have one side equal to 0, and then you're going to have to do the star method. So we're going to say x squared minus 5x or minus 6x plus 5. So we want to draw our star. We want to label our pieces of our quadratic. So our a would be equal to 1, our b would be equal to negative 6, and our c would be equal to 5. And then we're going to plug into our star. So ax, a times c, ax, question mark, b, and question mark. So we are going to plug in, so 1x and 1x. In the top, we'll have 1 times 5, which is 5, and in the bottom, we'll have negative 6. Now, we want to find two numbers that are going to multiply together to give us positive 5, but then we'll add to give us negative 6. So if we want to multiply to get positive 5, the only way we can do that is positive 1 times positive 5, or negative 1 times negative 5. Now, we want to add to get a negative. So if we want to add to get a negative, that means we're going to have to go with the option where both of our numbers are negative. When we do negative 1 plus negative 5, we do get negative 6. So that means negative 1 and negative 5 will be the pieces that work. Now, I can't reduce 1 over negative 1, so I keep it. I can't reduce 1 over negative 5, so I keep that. So I'm going to have x minus 1 times x minus 5 equal 0. Now remember, from yesterday, when you are solving quadratics and you've got them in factored form, you're going to take each piece, each of your factors, and set them equal to 0. And then solve for x. So we're going to add 1 to both sides here to get that x is equal to 1. We're going to add 5 to both sides here to get that x is equal to 5. But just like on the last example, we always want to check for extraneous solutions. So we're going to take this 1 and this 5, plug them in, and see if they'll work. So when we are checking 1, we're going to say the square root of 44 minus 8 times 1 would just be 8 equals 1 minus 7. So 44 minus 8 would give you 36. Square root of 36, is it equal to 1 minus 7, which would be negative 6. So square root of 36 is 6, but 6 does not equal negative 6, so that means that 1 cannot work. This would be an extraneous solution. So it looks like it works, but when we plug it in, we see that it doesn't. All right, we're going to do the same thing for 5. So we're going to say the square root of 44 minus 8 times 5 would be 40. So 44 minus 40, and then we're going to plug in that 5 for your x on the right side, so 5 minus negative 7. Well, the square root of 44 minus 40 would be the square root of 4. And 5 minus 7 would give you negative 2. Well, the square root of 4 is 2, and 2 does not equal negative 2, so that means that 5 also will not work. And so 5 is also an example of an extraneous solution. Now, because we had two possibilities, when we plugged them in, we got two extraneous solutions. This would actually be no solutions because we don't have any that actually work. The last piece that you covered in Unit 4 was identifying quadratic and linear system solutions. So number 6 says, what ordered pair are the solutions of the system of equations shown in the graph below? So when you have a system of equations, you essentially have two or more equations that are paired together with the same variables that will work at the same time. So your goal is to try to find the x and the y values that you can plug into both equations to give you something that's true. Now, if you're looking at the graph, that's fairly simple because all you're going to look for in a system of equations is the place where your graphs intersect. So your graphs look like they intersect in two pieces, here, and you just have to give the coordinates for each of those pieces. So this coordinate is at 4, positive 2, and this one is at 6, positive 6. So you would have two solutions, 4, 2, and 6, 6.